Okay, so before we get into technical discussions, I just wanted to make sure to understand you guys better. So, those who have joined today, are you guys all from the same college or different colleges? Anybody?
Different, sir.
Different colleges. Huh? Okay, okay. But all of you are from Chennai, right? Uh, Aruna Gautam, can you rejoin? I think if I start recording, you will be removed from the meeting, so you have to rejoin. Okay, and have you guys studied the week one contents before you see in our IIT MBS? I'm talking about math. So have you guys seen what is a natural numbers? What are real numbers? Or what are
Yes, sir.
sets?
Yes, sir.
Relations, functions. That's all we have in week one. Okay. So if yes, then how shall we go ahead with today's session? So shall let it be you ask me question and I answer to it, or we will start discussing a topic and in between if we have any doubts, if you know something, you teach me and we share our knowledge among ourselves.
We'll discuss, sir.
We'll discuss. I think only Atendran is talking to me. Um, what happened to others? Do you guys just wanted to listen? If you don't wanted to speak, at least type something in chat that you are there, or okay, one day left. Maybe I shouldn't ask those questions. Okay. Anyway, so see, our program has started 3 years ago, and this is our 10th time we run Math 1 DS. So based on the 9 terms that has happened earlier, so we have some data, and based on that data, we felt relations and functions is one such topic which is difficult for most of the kids. So that's our data. Okay. Okay, Nagaraj. So maybe we will start discussion on relations. What do you guys say? Is it okay? Or shall I start from the beginning? Like what is a natural number? Uh,
We'll do from relations.
we'll do from relations. Can I get some thumbs ups at least? Like if you guys agree. Or I will just start with what is a natural number, then move to integers, then move to real numbers, rational numbers, real numbers. And then we talk about sets, collections, and Venn diagrams on sets, properties of sets, and then talk about relations. Okay, okay, I got two votes for starting from relations. Jayashree and Sahitya, would you
We can
like to
start
vote?
with relations, sir.
Let's start with relations. Okay, okay, fine then. Let's start. Let me share my screen. I have a small presentation on relations. So I hope my screen is visible. Yes.
Yes.
Yes. Okay, so we will start with relations, and if we face any difficulty in understanding while we discuss this, if we need any prerequisites, then we will go discuss that and come back to this. Okay, so yeah, again, my name is Srikant Venkateshan. I have been the course instructor for almost 3.5 years, right from the beginning. So I have taught many courses like math, stats, even machine learning foundations, and in degree level, I have also taught many mathematics courses. I more or less teach math and stat courses. And yeah, that's my intro. I have done my master's in mathematics from IIT Madras. and currently pursuing PhD in electrical engineering from IIT Madras. Okay, so that's all about mine. And now let's start discussing about relations. So as we all know, relations can be of multiple types. But in our week one, we primarily focus on binary relation. Okay, what is a binary relation? A relation R, so we label it as R, and this relation is defined on two sets, between two sets. Let's say A and B are two sets. Okay, now a relation will be defined on these two sets, and that is basically the collection of ordered pairs. So it's an ordered pair. Pair means comes with double. So it's an ordered pair. What do we mean by ordered? Can anybody tell me what do we mean by ordered pairs? What is the difference between pair and an ordered pair?
It follows a particular order, sir, like
Right.
ascending order, descending order.
So yeah. So if it is A comma B, if it is coming like a pair and A comes first and B comes next, then that is not equals to B coming first and A coming next. So order is important. And when we mention that ordered pairs, that simply implies that small a comma b is different from small b comma a. So this pair is different from that pair. Okay. When we doesn't care about order, a comma b is same as b comma a. Okay. So this relation is basically you take an element in a set A and you relate it with to one element in set B, and that combination is called a relation between those two. Okay. So that is simply a relation. You connect one element from set A to the other element to set B, and that forms a relation. So what it says, if some element 2 is in A and 4 is in B, then 2 comma 4. So this ordered pair 2 comma 4 can be an element in the relation R. So R is also a set. So relation is also a set. But in this particular set, the elements will be in pairs, not simply like 2, 4 and all. It will be like an 2 comma 4. So 2 comma 4 will be an element in the relation R. Now a couple of examples will give us some intuition, more intuition. Let's say A is a set that contains 1 comma 2 comma 3. B is another set which contains x comma y. Now there you can define a relation R such that it contains these elements 1 comma x, 1 comma y, 2 comma x, 3 comma y. So where you see 1 coming from set A, x coming from set B. So 1 comma x is a element in R1. Similarly, 1 coming from set A, y coming from set B, 1 comma y now forms a pair, ordered pair, and it becomes a relation. It comes in the set relation. Similarly, 2 comma x and 3 comma y. So this forms a relation, right? Not only that, so if you have in real life, if you see, you can have a set with names and another set with gender. So this name set contains Abhi, Bhuvna, Charan, and gender set contains boy or girl. Now you can define a relation where you can map Abhi. So you can take Abhi and map that Abhi to boy, and Abhi comma boy now becomes an element in the relation. Similarly, Bona comma girl and Charan comma boy. So this R2, which contains these three elements, forms a relation. So it's a relation between the set names and the set gender. Okay. So now you tell me. So I have given a set A and set B, and I said R3, I defined it like this. So will this R3 can be a relation or it cannot be? So this relation, I assume that it is from A to B. Is this a relation?
No, sir.
No. I hear one no. Let me see. replies in chat. Okay, okay. Nikhilesh replies no. So 2 people says no. Okay, can I get the reasoning also, please? Why no?
Sir, the third element is not ordered set. It is B to A when all the other elements are from A B.
Correct. So whatever the elements you see here, you see B comma M, where B comes from set A and M comes from set B. So from the first element, it says that this is a relation that is defined from A to B. Similarly, if you check the second element also, the second element also says that the first element is C, which is in set A. The second element in this pair is from B. So from this pair also, we see that this is a relation defined from A to B. But if we move to the third element, what happens is in the third pair, N comes first and A comes next, which says that this element, this pair is actually a relation from B to A. And if I have to talk about a relation, once I am talking about a relation, it is always that this relation is defined from one set to another set. So all the elements that are there in this relation should be, the first element should always be the from set. The second element in the pair should always be to set. So from to. So from set A to set B. Okay. But this third pair collapses everything, which makes this element collapses everything. So the correct, so if we have to make it as a relation, the correct pair to be kept as the third element is A comma N instead of N comma A. Right? Now R3 is a relation from A to B. So order of an element inside a pair definitely matters. Okay, N comma A and A comma N are different. And in a relation, the order of an element inside a pair is definitely matters a lot. Matters a lot means it changes the relation completely, and it will not be a relation basically. Okay, in order to be relation, you have to be very, very careful about the order. Okay, so that is what I have written here. So N comma A is not equals to A comma N. Okay, so that is binary relation, and there are a lot of properties for a relation. You have studied, you would have seen reflexive relation, symmetric relation, antisymmetric relation, asymmetric relation, transitive relation, equivalence relation. So among these many relations, we primarily focus on reflexive, symmetric, definitely, but not antisymmetric and asymmetric. We will not be touching that. And again, transitive and equivalence. So this reflexive, symmetric, transitive, equivalence we will study. We will not focus on antisymmetric and asymmetric too much onto it. But if you wanted to know what antisymmetric and asymmetric is, now that everybody have internet, you can just Google it and you can understand the definitions of that. But that's not important to our particular course. Okay, and these relations is defined from a set A onto itself. Okay, now we don't have any set from one set to another set. So these properties will hold only on the set. So the relation formed from the set onto itself. So that means A maps to A, set A maps to set A. So you form a relations from set A to set A to the same set A. Okay. So for those relations, these properties hold. And let's go one by one. Any doubts so far? Yeah, I hope no doubts. Silence, I take it as no doubt.
No doubt, sir.
So we'll just move on to each and every relation. So what is a reflexive relation? Now, if you take any relation R, a binary relation R on a set S. So on a set S means from set S to set S. Relation defined from set S to set S. This is onto the same set S. Okay. So we simply say let R be a binary relation on a set S. Okay. So that is self understandable. Okay. Now, if you have a relation R and this relation R is said to be reflexive, IIF implies if and only if for all x, for every element in set S, you have x comma x, this element in your relation R. Okay. If your set S has 3 elements, let's say 2 comma 4 comma 6, then in your relation R, you should have 2 comma 2, 4 comma 4, 6 comma 6, all 3. So you see this for all. Okay. So for all implies if you have 3 elements in your set S, then definitely those 3 elements will form pairs among themselves, just like here 2 comma 2, 4 comma 4, 6 comma 6. And even in your relation also, you will have 3 elements like this. If it contains, if your R contains these 3 elements, then your R is said to be reflexive. Okay. So now I have another set P, which is pen, pencil, eraser. Now I have defined another relation R2, which has these many elements: pen, pencil, pen, pen, eraser, eraser, pencil, pencil. Is this relation reflexive?
Yes, sir.
Yes. Why?
No, sir.
Okay, no. Why? So if yes, why? No, why?
Sir, every element in P is related to P, sir. There is pen, pen, eraser, eraser, as well as pencil, pencil.
Okay. Okay. So
Yes, sir. But along with that, there is also pen, pencil, and eraser pen, which do not come in this thing.
okay. Yeah. So this is a very common misconception that can arise when we talk about reflexive relation. So do we conclude the relation which has only the image pairs as reflexive, or if it contains any extra thing, can we call it as a reflexive or not? So just
Sir, we
like
can
this
call it a
example.
reflexive, sir, if it has any extra thing.
Correct, correct. So reflexive relation doesn't say that it should contain only these pairs. It only says that these pairs should be there in the relation. If they are there, that is sufficient. You don't care about the other elements. So what do we call if it has only those elements, those image elements? Let me call them as image elements. So x mapping to x, like this 2 comma 2, 4 comma 4, 6 comma 6. So if it has only those, that is called identity relation, which is different from reflexive relation. Identity relation means every element in set S will map to the same element, and this forms a relation. That relation is called identity relation. So identity relation contains only these x comma x pairs, only these x comma x pairs, nothing more. But reflexive relation can contain extra pairs along with these x comma x. Okay, so that is reflexive. To understand the difference between identity relation and reflexive relation, reflexive relation can contain extra elements other than the self elements, so image elements. So here image elements are simply pen, pen, eraser, eraser, pencil, pencil. You just check whether those are there or not. If they are there, then that particular relation is called reflexive relation. Okay, so you just have
Okay.
to search for those elements. So if your set S or P, let's say P, if your set P has 3 elements, you just have to check for those 3 elements which are pen, pen, eraser, eraser, pencil, pencil. If they are there, then that particular relation is reflexive. No matter, you don't care about other elements, how they are. what they are. Okay, so that is reflexive relation. So yeah, let's slightly make our lives difficult, and let's try to solve difficult questions. Okay, let's say you have a set A, which is set of natural numbers. Okay, so this set A is a set of natural numbers, and now I define a relation. I collect all the pairs x comma y. Okay, all the pairs x comma y, where x and y both are coming from the set A, and this relation satisfies the condition that x plus y is even. Okay, so if you have pen and paper, I recommend everybody to have a pen and paper with you when you attend math sessions, because we rigorously do solve problems. So in the next session, which is on Saturday, we just solve the problems, just solve different kinds of practice graded. Even I will solve some type of graded questions also for you. Okay, so have a pen and paper with you. Just take a minute and try to analyze what is set A and what is this relation R3. And the question is R3 a reflexive relation or not?
Sir, R3 is reflexive relation, sir.
Okay,
Yes, sir.
so Nicholas says
Because every
R3.
element in the natural number is mapped with its own number.
Sorry, because
Sir, every element in the natural number is mapped with its own element. So 1 plus 1 is 2 and 2 plus 2 is 4. So that it's possible.
okay. So yeah, more or less you are correct. Your answer is correct, and the reasoning also 90% okay. Is there anybody? Yeah,
Sir, it is reflexive, sir.
yeah. Why is it reflexive? For
Sir, if we
reflexive, remember reflexive, you have to show me that all the elements which are present in set A, it should have mapped to its own element, and that should belong to R3. But that should be in your mind. Yeah, Atendra.
sir, uh, for a any number when added to itself will give an even number, sir. So any number can match with itself, and it can match with any odd or even number, sir, depending if it is odd or even. So it
Correct,
is reflexive.
correct. Great, good. So yeah. So our set A. So whenever you are confused with problems like this, just write down explicitly. So we have just mentioned giving it as notations, right? And such that n belongs to natural number, set of natural numbers. So if you are confused, just write it down. What are the elements that are contained in A? A contains 0, 1, 2, 3, 4, 5, 6, 7, and so on to infinite. Now, if 0 is in A, if R3 should be reflexive, 0 comma 0 should be in R3. Similarly, if 1 is in A, 1 comma 1 should belong to R3. 2 comma 2 should belong to R3. 3 comma 3 should belong to R3. And so on and so on. 10 comma 10 should belong to R3, and so on and so forth. Right? Just check whether these will belong to R3 or not. If at all it has to belong to R3, the only condition is when it is coming as an x comma y pair, you add x to y and see whether it is even or odd. So when you add 0 to 0, it gives you 0, which is even. When you add 1 to 1, it gives 2, which is even again. So 1 comma 1 will also be in R3. Now 2 comma 2. 2 plus 2 is 4. 4 is an even. It will so 2 comma 2 will be in R3. Similarly, you take any element small a in the set A comma a, if you add a to a, it will be 2a. 2a is always even because 2 times a. 2 times any number is always even. So therefore, for all the elements in A, it will be mapped to its own element for this particular relation, and every pair will contain in R3. So you take any element A, small a comma a will be in your R3. So therefore, so therefore R3 is a reflexive relation. So is R3 an identity relation?
No, sir. It's only reflexive.
It's only reflexive because there will be other
Because
elements also. Yeah, there will be other elements also present in R3. Like 0, comma 2 will be in R3, 2, comma 4 will be in R3, 9, comma 11 will be in R3, 101, comma 203 will be in R3. So it will only be reflexive. It will not be identity. Okay, and this is the proof. So for every n which is in A, n comma n will be in R3 because n plus n is 2n, which is in. Okay. Now my next question will be, I have defined R4. Okay, and now R4 is all the pairs x comma y, and x comma y comes from both x and y comes from set A. Now x plus y is odd. Is this relation a reflexive relation?
no, sir. It will not be reflexive.
Okay, Nicholas says it will not be reflexive. Others just think.
No.
It won't be reflexive, sir.
Okay, so Atendran also says it won't be reflexive. Can I get more answers? If people are trying, I can wait. So I can see, yeah, Jayashree, Magesh, Satya, Runa. So think about this. So again, as I said, if x plus y is odd, you just write down what all elements that can be in R4. Okay, fine. Let's proceed then. So as Niklesh and Atendran said, this won't be a reflexive relation because again, if in order to be reflexive, 0 comma 0 should be, you just take the first element 0. If 0 is in A, 0 comma 0 should be in the relation in order to be reflexive. Just check whether 0 comma 0 will be in R4 or not. In order, if 0 comma 0 should be in R4, 0 plus 0 should be odd, but 0 plus 0 is even, which fails the condition to be in R4. Therefore 0 comma 0 will not be in R4. Hence you can say that this will not be a reflexive relation. Okay, let's move on. Let's talk about symmetric relation then. Now previously we said, remember that for all conditions, so if you have n elements in your set A, then you should definitely check for all the n elements, okay, for reflexive. Whereas the upcoming relations, that for all condition will be vanished. It won't be there. So the conditions will be like this. So let's say R is a binary relation on some set A, some set S, and then R is said to be symmetric if and only if for every x comma y in the relation R, you should have y comma x in your relation R. So now set S is gone. So you don't care about how many elements are there in set S. You only care about the elements which are there in the relation set. If in that set, if you have x comma y, then you should definitely have y comma x, which makes the whole relation for every x comma y you see in your relation R, there should be y comma x. That should also be in R. Only then you can say that is symmetric. For example, again, now we change the numbers. Let's say your set S contains 5, 10, and 20. Okay. So you don't worry about how many elements are there in set S. So you just need what are the elements. That's it. Now move on to the relation. In your relation, you have, now you can see in R1, you can see there are 5 elements present. So what you have to do is you should start from the first element. Just take the first element. First element is 5 comma 10. 5 comma 10. Now 5 comma 10 is there in R1. So definitely there should be 10 comma 5 in order to conclude this R1 as symmetric relation. Okay. So if you see 5 comma 10, you go check for 10 comma 5 in the same set, in the same R1. If you check, there is 10 comma 5 at the fourth place. So 5 comma 10 and 10 comma 5 forms a pair. So 5 comma 10 is there, so 10 comma 5 is there. So this, with respect to these two elements, this is symmetric. So now the first element satisfies the symmetric relation property. Now just move to the next element, which is 10 comma 20. Right? 5 comma 10 we checked. Now move to the next element, which is 10 comma 20. Now 10 comma 20, for 10 comma 20, we need to have 20 comma 10 in order to conclude this particular relation as symmetric relation. So now 10 comma 20, you go check for whether there is 20 comma 10 is available in R1 or not. If you check, there this third element is 20 comma 10. So this 10 comma 20 and 20 comma 10, this forms a pair, and with respect to this 10 comma 20 and 20 comma 10, this particular relation R is symmetric. So 5 comma 10 has 10 comma 5, 10 comma 20 has 20 comma 10. Now 20 comma 10 has 10 comma 20, and 10 comma 5 has 5 comma 10. So for first 4 elements, symmetric property is satisfied. Now you just move to the last element. So you have to check for every element that is present in R. So in your relation. Okay. Now 20 comma 20. So here x is equals to y. So 20 comma 20 has 20 comma 20 only, the same element. So you can have the same element. So for 20 comma 20 also, it has 20 comma 20 in R1. Therefore, all the elements in R1, for every element, you pick any element you pick, which is x comma y, it has a symmetric element y comma x in R1, which makes this relation R1 a symmetric relation. Not asymmetric, which makes this relation symmetric relation. Okay. So R1 is a symmetric relation. Now this is again a question to you guys. So I define a set R2, relation R2 on the set of integers. So Z represents integers. So all the pairs A comma B, where A and B both belong to the set of integers. So I hope everybody know what is a set of integers is. And the relation is, if A plus B is less than or equals to 15, then the pair A comma B will be in R2. So that's the condition in order to be in R2. Now tell me whether this relation R2 is symmetric or not.
Symmetric, sir.
Okay, symmetric. Okay. Any more answers? Okay, let me know this first. Are people able to
Sir,
get
it
this?
is symmetric, sir.
Okay. Are people able to get this, or you guys are confused? Let me take inputs from those who are not replying. So are you able to get what I am trying to convey, or you get lost somewhere and just sitting here because your parents wanted you to sit in the session? Something like that. Okay, you don't want to reply for this also. I don't know. I like interaction more. You can just interact. See, the thing is, if you interact more, we will just learn. That's it. You will learn more. Yeah. Any more answers? Yeah, Atendra.
Sir, it is symmetric, sir.
Okay. Yeah. So as everybody said, this is a symmetric relation. So before concluding, you just write down what kind of elements that can be in R2. So this is a random example. I just took 4 elements. These are not the only elements. So elements like this, 0, comma 1, minus 2, comma 4, which adds to which if you add those two elements which inside the pair, that should be less than 15 or equals to 15. So these kind of elements you can have in R2. Now, if they are there, you just see the symmetric element of them. So 0, comma 1, you know it will be in R2. Then you have to check whether 1, comma 0 is in R2 or not. So if you take minus 2, comma 4 as one of the element or any other element, 1, comma 3 will be here. So if you know that 1, comma 3 is in R2, you just check whether 3, comma 1 will be in R2 or not. If you check, it will be there in R2. So because if you add A plus B or B plus A, both are same. So adding A to B or B to A, both will be same. If A plus B is less than or equals to 15, B plus A will also be less than or equals to 15. Like this. If you pick any pair P comma Q in R2, so P comma Q belongs to R2 means P plus Q is less than 15. If P plus Q is less than 15, Q plus P will also be less than 15, which tells us that Q comma P will also be in R2. So this is just a simple mathematical proof. So I just don't want it to show, but we'll just give you an exposure. So if you in degree level, if you join this program and in degree level, you would be coming across these kind of basic proofs in mathematics. So this is a very simple proof, one line proof, where you can we will better appreciate mathematics. Okay, so this is very simple proof. If you know that P comma Q is in R2, you just have to prove that Q comma P will also be in R2 to make this R2 as a symmetric relation. And this is a simple proof, which finally implies that R2 is a symmetric relation. Okay. Now let's take another example R3, which is x comma y, and x comma y comes from the set of males in this world. Okay. And the condition is x is brother of y. So can this relation R3 be a symmetric relation?
Yes, sir, it is symmetric.
Yes, sir.
Yes. So if x is
Yes,
brother
sir.
of y, y will also be brother of x.
X.
Correct. So if x comma y
Yes,
is
sir.
in R3, then y comma x will also be in R. So that's it. That's the reasoning. If A is brother of B, then B is brother of A. So if for all A comma B in R3, you will have B comma A in R3. So there are a couple of more examples. Now we took this example previously also. Now tell me whether this is not reflexive. Okay. So we just saw a couple of slides ago, we just saw that this relation R4 is not reflexive. Now can you tell me, is this relation R4 is symmetric?
Yes,
Yes,
sir.
sir.
The relation is symmetric.
It is symmetric, right? Again,
Yes,
how
sir.
can we how can we conclude ourselves that we are true?
Sir, because
Simple.
x plus y is odd, then y plus x should be odd.
Correct. Exactly. So if again, so this is the best reasoning. What Nikhilesh or who gave this?
Yes,
Nikhilesh,
sir.
is that Nikhilesh? Yeah.
Nikhilesh. Yes.
So it's a one line reasoning. But if you are still confused, just write down the elements that you feel that will be there in R4 and just see its symmetric element will be there in R4 or not. So you will see that if m plus n is odd, n plus m will also be odd. Therefore, if you have m comma n in R4, then definitely n comma m will also be in R4, which makes this R4 is symmetric, but this is not reflexive. Okay, so there will be relations which are not reflexive but symmetric, reflexive but not symmetric, all kinds of variations. So you can come up with examples. So this is a good exercise to try out. You guys can try it out. So you just create relations which are reflexive but not symmetric transitive, which is symmetric but not reflexive transitive, which is transitive but not symmetric and reflexive. So you can try it out, all sorts of things. So now this is also another good example. This is a relation which is a comma b, or pairs a comma b which are coming from integers, set of integers, and the condition is a minus b is 10. Is this relation a symmetric relation?
No, sir.
No, sir.
No. So this will not be a
No.
symmetric relation. Again, for
Yes.
simple understanding, you write down few elements that you feel that will be there in this R5. So I thought 10 comma 0 will be in R5 because 10 minus 0 gives me 10. 20 comma 10 will also be in R5. Similarly, minus 25, minus 35, 200, 190, all these things. Now, my only thing is to check whether 0 comma 10, 10 comma 20, minus 35 comma minus 25 are there in this relation or not. So if I check 0 comma 10, if 0 comma 10 should be in R5, then 0 minus 10 gives me minus 10, which is not equals to 10. So this fails the given condition for to be an R5 element. So therefore, this won't belong to set R5, relation R5. Okay, so if you see 0 minus 10 gives me minus 10, 10 minus 20 gives me minus 10. So R5 is not symmetric. Okay. So how much time we left? We still have 10 more minutes. So any doubt so far? So reflexive, symmetric. Okay.
No, sir.
Okay.
So just one doubt, sir, in the course.
Mhm.
Sir, in week one assignment, the first question, I don't know
Practice
how
or graded?
practice, sir, non-graded.
Okay.
Sir, there were 8 natural numbers, but the answer was showing 9, sir.
Activity questions, huh?
No, sir. Week one, non-graded questions. Yes, sir.
Week
Activity
one,
questions.
week one, lecture 1.1, right? AQ. So below is a list of numbers, and you have been given some numbers, and how many natural numbers are there in the given list. That's the question, right? Is that the question?
Yes. Yes,
Okay.
sir.
Okay, I see 22, 47, 0, 1, 43, 1729, 6174, 100, 32. I see 9, right?
Sir, 0 is a whole number, no, sir.
So I know this is a very big confusion among most of the students. See, whole numbers you would have studied in your schools or colleges. It's just a convention, okay? So it is not sacred that 0 is a whole number and you should not include them in to the set of natural numbers. Okay, so it is just one convention where you separately study about 0. You don't include them it to be natural. But whereas if you have watched our first lectures, the way in which we define our set of natural numbers is by counting. So natural numbers are used for counting purposes. So that's where these numbers arise. So if you don't have anything to count, that is referred to as 0, and 0 can also be a natural number, and that's how this is our convention. Okay, so there are I will ask the team to upload frequently asked questions. So this is a very frequently asked question, and we documented this with a solution. So what's the solution? Okay, so just read that solution. So it's just a convention. Okay, so do not worry much about whether to include 0 or exclude to 0. It is one way we say 0 you include in the set of natural numbers because that is how we define natural numbers. Okay.
Yes, sir.
Huh. So in this particular course, always remember that 0 is a natural number, and we do not talk about whole numbers at all. There is no whole numbers, just like Shah Khan says. So whole numbers is not in our dictionary. Okay. So
Okay,
we
sir.
have only natural numbers,
Yes.
then integers. Okay.
Yes.
Yeah.
Got it, sir.
Great. If I start transitive, I think we won't be ending this lecture by 7 p.m. Let's do one thing. So if you have any doubts till transitive, till symmetric, we can discuss. If you have any doubts in activity questions also, happy to discuss this within this last 10 minutes. And on Saturday, we will discuss about transitive relation and solve couple of problems. Okay, we will solve problems so that you will get some hands-on experience in
Okay.
problem solving. Okay, so I will come up with some 5-6 problems maybe. Okay,
Yeah.
so we
Okay.
will try to solve those 6 problems, and you can also come with the problems you have. We will solve everything together on Saturday. Okay,
Okay.
Saturday I will be taking the session. Maybe from next week I will only take one session, and the other session I will give it to a TA. But this first week I will be taking both the sessions, so I can be little bit liberal. So I can arrange my sessions.
Okay.
Okay. Yeah. Any now I will just open it for doubts. If you have any doubts, you can ask, or else it's a 7-minute break to all. So I will leave you guys 7 minutes early. Okay.
Okay, sir.
Any
Thank you, sir.
doubts? No.
No, sir.
No doubts.
Okay. Fine. Then let's meet on Saturday. Thanks for
Yeah.
joining and have a great day.
Thank
Bye.
you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.